This is the June 22nd, 2023 Physics Regents Part B2. Now, if you see here, I have already written some stuff because it would have been hard to do it on the computer, so I'm just going to explain this part when I get to it. As of question 51, determine the potential difference across the battery. So, if we use our physics reference table right here, in a parallel circuit, and we know it's a parallel circuit because the current can pass through many branches, we know that the voltage is always the same in any point in the circuit. So the potential difference, which is in other words, the voltage will always remain the same. So it is 12 volts. Okay, next, question 52. Determine the current through the 6 ohm resistor. So the resistance is equal to voltage divided by current, which means that current is equal to voltage divided by resistance. Now, what's the voltage? The voltage is 12 volts again, but the resistance is 6 ohms because it's asking for this resistor. So it's just 12 divided by 6, which is 2 amps. Wait, 2 amps. Okay, you know what? Let's just use this text box. 2 amps. Okay. Calculate the equivalent resistance of the circuit. So since it's a parallel circuit, the equivalent resistance will be this formula. 1 over the equivalent resistance is equal to 1 over the resistance of one resistor plus 1 over resistance of the second, etc. So let's use the text box again. Text box. So in this case, 1 over the equivalent resistance is equal to, okay, let's 1 over the equivalent resistance. Okay, wait, let's redo this. 1 over the equivalent resistance is equal to 1 over resistance of the first resistor plus 1 over the resistance second. We only have 2 resistors, so we don't have to worry about the third one, which is equal to 1 over 3 plus 1 over 6. Now the common denominator here, you have to multiply by 2, which means that to add fractions, which means that it's going to be equal to 2 over 6 plus 1 over 6, which is equal to 3 over 6, and then 3 over 6 equals 1 over R equivalent. Now, what we have to do is to solve for R equivalent, we have to take the inverse. Which means, if we take the inverse, 6 over 3 means 2 ohms. In the real exam, you would of course have to use the units, but for this, there is no, on the keyboard there is no ohms symbol, so I'm going up without units, but on the test you use units, of course. The diagram below shows parallel straight wavefronts approaching a rigid barrier that has a small opening in its center. On the diagram in your answer book, draw 3 wavefronts. Okay, so when we have these parallel wavefronts approaching a barrier, the way the waves diffract is they have to spread out like this. That's wave diffraction. It's not clean, but that's how it's supposed to be. So if you think I'm just throwing a rock or a pebble in the water or anything, the the way the waves are gonna diffract is like this. In the image you see here, they're gonna diffract. You can try it if you want. Okay, that's it for 55. 56. A projectile is launched from level ground with an initial vertical speed of 26 meters per second upward and initial. So okay, so the initial vertical speed in the y direction is 26 meters per second, and the horizontal speed VIX is 15. Okay. Calculate the total time the projectile is in the air before the projectile returns to the level ground. Okay. So if you imagine you have a projectile here and you launch it, it goes back down right here. VF for the final velocity will equal 0. Because if you throw a baseball or whatever, a basketball, at its highest point, the speed is gonna be 0, which is why it goes back down. So if we have like here visual representation, 1 second. Right here, so this is 15, this is 26. That's how it would look like. Okay, calculate the total time the projectile is in the air. Okay, so what formula we can use? We have the acceleration, which is negative 9.81 at its maximum point. We have the initial vertical speed. We have the final speed. Okay, so the formula we can use, it's in the kinematics. We can use this formula, Vf equals Vi plus At. We have the final velocity, we have the initial velocity, we have the acceleration, we only need the time. So let's see here. Let's bring this up. So we can use Vf equals Vi plus At. Okay, let's create that like that. Plus 8. Okay, let me just redo that. Vf equals Vi plus At. Okay, which means is that Vf is 0, so okay, 0 equals, let's use that, 0 is equal to Vi in the y direction, because we're talking about the y direction, equals 26 meters per second plus negative 9.81 meters per second squared times the time. So you move 26 on the other side, you get negative 26 equals negative 9.81. Divide both sides by negative 9.81, and you should get 2.t equals 2.65 seconds. But the problem with this answer is that this is the time it takes at max height. We're trying to find when it returns to the ground, so we're trying to find the full time. So at half of it, it's 2.65. The total time, you just multiply this by 2, which means that the final answer will be time equals 5.3 seconds. That's the final answer. Determine the total horizontal distance a projectile travels before the projectile returns to the ground. Actually, oh, I was talking about returns to the level ground here. I was looking at the wrong question. Before the projectile returns to the ground. Okay. So we have the horizontal speed, 15 meters per second. So we can use, see, one of these kinematics. V equals d over t. Yes, we can use the first one. Actually, yes. We can use V equals d over t. Okay, yes. So that means d multiply both sides by t. D is equal to v t, which means, since we have the given time, d is equal to the velocity in the horizontal direction, which is 15 meters per second, times the time of 5.3 seconds, which will give you approximately, let's put the answer up here, 80 meters. That should be the answer. Okay, determine the angle above the horizontal. Okay, so any angle in projectile motion used above the horizontal, that's a key word. Use tangent, inverse tangent of the vertical component a y over a x, which means the vertical, so it's the speed in the y direction divided by the speed in the x direction, which is equal to inverse tangent of 26 meters per second over 15 meters per second. Let's take that in. Oh, take the inverse. Okay. And make sure your calculator is in degree mode. So let's see. So I get 60 degrees. Okay, that should be it for that one. The next one. A 20 Newton force due east and a 25 Newton force due south concurrently at point P. The diagram shows a vector drawn to scale representing 20 Newton force due east. Okay, this is the one in the beginning of the video that I said I did already because it would have been hard. It would have took a long time to draw on here. So basically, the 20 Newton vector you have given here, you use a ruler and you measure how many centimeters it is, and then it's 20 newtons obviously, and I measured it as 4 centimeters. You divide 20 by 4 to find the scale, just 5 newtons per centimeter. So 5 newtons equals 1 centimeter, or 1 centimeter equals 5 newtons. It doesn't matter. And then on the diagram in your answer booklet, use a metric ruler to draw a vector to represent a 25 Newton force. So if we have 5 newtons equals 1 centimeter, 25 newtons is equal to how many centimeters? So you could do a proportion. 5 newtons over 1 is equal to 25 newtons over x. Cross multiply, you get 5x equals 25. Divide by 5, you get 25. Divide by 5 is 5. So then you draw with you use your ruler and you draw 5 centimeter vector and you just label it 25 newtons. That's it. And yeah, determine. Oh, this is actually a wrong part. That was meant to be there. Determine the magnitude of the resultant force acting at point P. Okay, for this, you just basically have to use the Pythagorean theorem because this is a right angle. You do 25 newtons squared plus 20 newtons squared is equal to, let's just say resultant squared, and then just you square those and add them, and r squared 20, you get 1025 newtons squared equals the radius equals resultant squared, and take the square root of this, and you get 32 newtons, which means that this, if we were to draw a vector, this would be 32 newtons. Okay, it's not straight, but I just drew it. You know what? Let's do so you can see it better. Newtons. Determine the amount of energy in electron volts that must be absorbed by a hydrogen atom to excite the atom from the n equals 1 energy level to n equals 4. Okay. So, where's hydrogen? Since it's hydrogen, n equals 1 is the negative 13.60, and n equals 4 is negative 0.85. So okay, you know what? Yeah, let's go back to the EI minus EF, which means that negative 13.60 electron volts minus negative, oh, this should be inside, yes, minus negative 0.85 electron volts. And you can use the absolute value. I'm going to do the absolute value. Doesn't matter if it will give you a negative answer, but it doesn't matter if it's positive or negative. Doing that, and then you just add these. So negative 13.60 plus 0.85 electron volts will give you 12.75. 12.75 electron volts. Determine the sign and magnitude of the net charge in coulombs of a particle that has a core composition of bottom. Okay. So where is that on the reference table? Okay, right here. So bottom is negative 1/3. If we have 3 bottoms, negative 1/3, negative 1/3, negative 1/3, that's the same thing as negative 1. but it's asking for coulombs. That's elementary charge. So what's -1 elementary charge? That's the same thing as -1.60 times 10 to the -19 coulombs. That's your answer. And the last one of this set, what type of electromagnetic radiation would contain photons, each having an energy of that joules? Okay, so you have to see right here. You have to use this. Energy of photon equals Planck's constant times the frequency. And so Planck's constant is 6.63 times 10 to the -34 joules times seconds. So energy is equal to Planck's constant times frequency. Frequency is equal to energy divided by Planck's constant, which is equal to 2.65 times 10 to the -20 joules. Divide that by Planck's constant, which is 6.63 times 10 to the -34 joules times seconds. And that should give you 4 times 10 to the 13. And then if you go on the electromagnetic spectrum, you're going to see that the frequency with a power exponent of 13 is equivalent to infrared. So the answer is going to be infrared. So let's just put that in. And that will be it for this video. The next part, we're going to do part C, the last part of this short response set.